Hello Year 7 and welcome to another lesson. Today's lesson we're going to look at the highest common factor. I know we've already looked at the highest common factor using the Euclidean algorithm, but we're going to look at it in another way. But before we start, I have a puzzle for you to do. So what I'd like you to do is to pause your videos and take a few minutes and see if you can find all the numbers less than 50,000 that have exactly 11 factors. Okay, so please pause your videos or these clips and actually have a go at solving this question. Okay, good. So I assume you've all paused your videos and it's at least 20 minutes or so later and you've had a good think about solving this question. Now, the very first thing to notice about this is with 11 factors, well, 11 is an odd number, obviously, and we learned before exactly what kind of numbers have an odd number of factors, and those are the square numbers. So we know right away that we're looking for square numbers, but it doesn't mean we can have every square number. You know, 9 is a square number, but 9 certainly doesn't have 11 factors. 25 doesn't have 11 factors. So we want to find all the ones with exactly 11 factors. Now, let's just take a quick look at just a completely random number, okay? And I'm just going to let's do 2 squared by 3 squared. So this is going to be, of course, 4 by 9, which equals to 36. So what we're going to do is we're just going to work out, is 36 actually one of our numbers or not? And let's work out how many factors 36 has. Now, hopefully you guys know that we don't actually need to be multiplying them each time, because I go, how many options for 2's? I could have 0, 1, or 2. 2's, because I could have a 2 to the 0, a 2 to the 1, or a 2 squared. And the same for a 3, a 3 to the 0, a 3 to the 1, or a 3 to the 2. So I know that the number of factors I have is 3 times 3, which is exactly 9 factors. And here they are. 1, 2, 3, 4, 5, and 6. And remember, 6 is the square root of 36, so now I can pair them up with their bigger pairs. And I'm going to have, and I completely lied about the 5. I'm not going to restart the video. I'll just get rid of the 5. Obviously, 5's not a factor of 36. So I'm going to have here 9, 12, 18, and 36 when I pair them up. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 factors. If you're wondering why that is, please watch the last lesson again. But one thing that I notice is that whenever I work out these factors, I'm timesing two numbers together. I'm timesing 3 by 3 and getting 9 factors. So that means I've got to times 2 numbers together to get 11, but I can't really do that because, look, let's just say I had 2 by 5 to the power of 4. I've just made this up. I know it's not really going to be a square number because the 2 is not squared. The number of factors would be a 2 times a 5, because I could have 2 to the 0 or 2 to the 1 and 5 to the 0, 1, 2, 3, or 4. So this number, whatever it is, would be have 10 factors. But 11's a prime number, so I can't actually times 2 numbers together to get 11 except for 1 and 11. So in fact my only options are things like 2 to the 10, because that'll have 11 factors, 3 to the 10, 4 to the 10, and so on and so on, because if I have two different prime factors, well, I'll then have two powers to times together, but I can't times together two powers and get 11 because 11's a prime number. So now I just work out what each of these is, and I get my calculator. You can get your calculator too, and you can go, okay, well, 2 to the 10, and working that out is 1024. Okay, 3 to the power of 10 equals to 59049. Oh no, we're already bigger than 50,000. So we cross that out. Obviously 4 to the 10 is going to be bigger. And we have this one here. And obviously it's a square number because you know your index laws. That's just 2 to the 5 all squared, because an odd number of factors means it's a square number. So that's the answer to this little problem, or this puzzle. Okay, let's move on. Now I'm going to ask you to find for me the HCF of 360 and 216. You may go, okay, that's pretty easy. We learned how to do that in the Euclidean algorithm. So here's some revision. I go 216 into 360. And I know 360 is 1 by 216 plus 144, because I've got 1 remainder 144. So then I get 144 divided into 216. 144 into 216 is 1 remainder 72. So 216 is 1 by 144 plus 72. I divide 72 into 144. 72 into 144 goes 2, remainder 0. So 144 equals to 2 by 72 plus 0. Now that should be nice and easy, and if anything, it's really just a bit of revision, and we have our HCF of 72. Alright, I want to show you another way of getting the HCF now. So what we're going to do is we're going to start with our numbers 216 and 360. We're going to do factor trees for each of them, which I'm sure you know how to do now, and a prime decomposition. So here is a prime decomposition of 216. It's 2 cubed by 3 cubed. An interesting note here, if you were paying attention in previous lessons, this means it is 2 times 3 all cubed, so 216 is actually a cubic number because I've got powers of 3 there and a power of 3 there. So I'm now going to get my 360, and I've got 2 cubed by 3 squared by 5. So what I'm going to do is I'm just going to slightly rewrite it, not very much, and I'm going to say this equals to 2 cubed by, and I'm going to pick 3 squared by 3. And then the 360 is going to be 2 cubed by 3 squared by 5. And you might be asking, why am I writing it like this? I didn't even change this one, but why am I breaking it up like this? I'm doing it so that I've got this first part here and this first part here are the same. And you can see that this is a common factor, okay? So this one only had a 3 squared, so I could only put a 3 squared in the common factor, which means this 3 had to stand out there by itself, not part of the common factor. So I've now got, okay, well, I know this is equal to 72 by 3, and this equals to 72 by 5. And that's just because 2 cubed is 8, 3 squared is 9, and 8 by 9 is 72. So then I easily found out my HCF, and our HCF equals to 2 cubed by 3 squared, because that was part of both of them, okay? And I wrote 2 cubed by 2 cubed again. I think I just said the word squared, and then that made me just think about squaring things and doing the same thing again. So there you go, 2 cubed times 3 squared. Okay, so we break this one up, and we break this one up until we've got the biggest possible part that I can fit in both at the front, and then the leftovers there which aren't part of the common factor. Okay guys, so I want you to have a go at the questions from Euler chapter 3, questions 1 to question 11. I showed you where the book was last time, and if you have any questions, please ask on your class's Google Classroom. Okay guys, thank you very much, and I'll see you in the next lesson.